Welcome to LIB Academy, and in this video we are going to look at the arrangement of atoms around the chiral carbon in 3D on a paper. Before we continue, let's look at what a chiral carbon is, or a chiral atom is. So a chiral carbon is a carbon with different groups attached to it. Say so looking at this carbon, it has 4 groups attached to it, but each of these groups are different. So we have hydrogen atom, we have bromine, we have iodine, and we have chlorine. So this carbon here has 4 different groups attached to it. We don't have hydrogen repeating. We don't also have bromine repeated on the same carbon. So this carbon atom here is a chiral carbon. And the carbon which has the 4 different groups can be called a chiral center. So if you are to look at it if you are looking for a chiral center in a given molecule, you look at the carbon that has 4 different groups attached to it. So now let's continue. In chemistry, the solid and dash wedge are standard notations used to represent 3D structure of molecules. So this symbol right here is the solid wedge, and this is the dash wedge, and this is just a solid line, a solid line. So now let's look at this chiral carbon here. You could see that we have chlorine on a solid wedge, and we have hydrogen on the dash wedge. So this this molecule is telling us that an observer is here, observing the molecule. So if you are here observing the molecule, the one pointing towards you, an observer, should be on the solid wedge. This one is out of the plane, pointing towards you. And the one on the dash wedge is kind of pointing outward, like moving away from the plane. Let's see this 3D drawing here. So this is an observer observing from point A, and this is the atom facing the observer. So the atom facing the observer should be on the solid wedge. And an observer here could see that there is a certain atom which looks like it's diminishing, like it's moving away from the chiral center. And the one moving away from the chiral center, which is Z here, should be on the dash wedge. It depends on the spatial arrangement of the molecule. If we have, let's say this atom is atom number 1 and this is atom number 2, the arrangement can change in such a way that we will have atom number 1 being on the dash wedges, which means moving away from the plane or away from the observer. So away from the observer and towards the observer should be towards the observer should be on the solid wedge, and away from the observer should be on the dash wedges. And those molecules which are just in plane are represented by the solid line. So if we look at this molecule right here in red, the observer is at point B. So you could see that this atom right here is facing directly towards the observer, and this is kind of pointing away from the chiral center, which is away from the observer. So this one right here will be on the dash wedge, and this will be on the solid wedge. So that is what you should know about dash wedge and then solid wedge. If you see them, you should try your best to know what they are trying to tell you. Now, we will be needing this in the nomenclature, RNS configuration of molecules. So one thing you need to know is drawing a 3D molecule, we don't draw them in such a way that the atoms will be 90 degrees apart. Right? We don't draw them like this one here. So this one is wrong because the atoms are kind of 90 degrees apart, 90 degrees apart. So this should be the right representation of a 3D molecule. So to sum up, the solid wedge is telling you, where the observer is, and the atom facing towards the observer will be on the solid wedge, and the dash wedge is the atom moving away from the observer, should be represented on the dash wedge. So that is it for this video. See you in my next video, where we will be looking at the RNS configuration of molecules. Thank you for watching. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye.